Sing through me, O muse, of a pull request so fine, which presents the change with clarity divine, where commits weave a tale both true and fair, so that no reviewer shall ever despair. This is a tale as old as time. It is a tale of empathy, consideration, caring, and also of sharing, communication, collaboration. It is a tale of a pull request. And what is a pull request anyway? It can be many things. It can be the last step, the final hurdle we have to overcome to bring our changes into the main branch. It can be request for feedback, cry for help. It can be a place where we evaluate, discuss, experiment with different ideas and approaches. And it can be a historical record of a change. And then perhaps it can be a stage, a special kind of a stage designed for a special kind of a dance we call code review. Now, this dance, it can sometimes be magical, magnificent, glorious. It can fill our hearts with joy and laughter. It can bring clarity and enlightenment to the team. It can make our code base a better place. And this usually happens only in a fairy tale. The reality, alas, is not quite so pretty. So, too often, participating in a review process is a gut-wrenching, soul-draining experience. It leaves us tired and exhausted from all the endless debates, pointless discussions, nitpicks, clashes of the egos, and whatnot. And if we're being honest with ourselves, reviewing is not like the favorite of activity that we do, right? Like, how often when you are asked for a review, when a PR is assigned to you, do you go like, yay, another PR, I'm gonna review some code, this is gonna be so great, I just can't wait to start. Doesn't sound familiar, right? It's probably more something like, again, another one, like, does it ever end? You know, I'm not thinking about this right now. Maybe tomorrow, if I'm in a good mood. And there are reasons for this, many reasons I will not go into, but I can recommend an excellent resource, a great book on the subject, which is aptly titled Looks Good to Me, by Adrian Braganza. So this is really a detailed treatment of code reviews. It is filled with a lot of practical advice that will help you improve this practice, make it a more pleasant experience, and reap more benefits out of it. But in this talk, I want to focus on one thing and one thing alone, and this is a pull request. And I want to submit here in front of you, my dear audience, that the way we create and organize our pull requests, the way we design and build this stage, in many ways determines the look, the feel, the shape, the appeal of this dance. And here's why. You see, when we assign a PR for review, we are essentially sharing information. And another word for this is called communication. And one of the key techniques of good, efficient, effective communication is organizing the information we share, making it more presentable so it can be more easily understood, digested, absorbed by our recipients, our reviewers. And there are three key pieces of information that we share when we assign a PR for a review. So there is the title, there is the description, and there are the changes to the code. Now, for the past few years, my main activity that I have been doing is reviewing code. You know, I've been doing this more than coding, more than anything else. I could literally put code reviewer as my job title on my LinkedIn bio, and the only reason I didn't do it because it doesn't really sound that appealing, right? But that's the actual truth. And in that experience, working with different people and teams, my strong impression is that we do a solid job, typically with first two bits of information, so the title and the description, and we predominantly fail. We completely neglect the last part, the changes to the code themselves. And there are many different ways how this is manifested. I'm going to mention just a couple of those. So the most obvious one is when the changes are completely stashed in a single commit. So everything is thrown at once to the reader. I'm going to come back and explain in more details why this is not right, but hopefully many of you already understand this. Now, another thing that I see quite often is when we have a bunch of commits. So there are a lot of commits, they are small, but they're completely nonsensical in their nature. So we end up with history along the lines of work in progress, or WIP, foo, bar, buzz, blah, more WIP, make it work, make it really work, make it really, really work. This time it's definitely going to work. org. Right? Sounds familiar, right? Now, this kind of history, it is completely useless even to the author, let alone to the readers. And so as reviewers, we have to take a look at the complete diff, and then this is basically just the same as the first thing, except it has this extra bonus of useless garbage, which are these commits. Okay? The third thing that I see also quite often is when there are some commits, and they seem to make sense looking at the titles, and we have history along the lines of update dependencies, add a new dependency, implement the entire feature, make the CI build work, and add the changelog entry. And so we have like this one mega commit which contains like 99% of the changes, and again, it's just more of the same. And this is quite unfortunate because in many pull requests, I would say in most pull requests, the majority of the information shared lies in the changes to the code themselves. And so many pull requests touch or change or modify like hundreds of lines of code. It's not uncommon to see a PR touching thousands of lines of code. That's quite a lot of information. And all this, there are like a different type of changes taking place in, like in such large PRs. So you could have changes to the database structure, aka migrations. You could have adaptations of the ecto schemas, modification of the business logic. Something maybe has to be refactored to accommodate for the new circumstances. Then we have presentation, aka interface logic. Then we have tests, documentation, and who knows what else. And all of this stuff is crammed into this single mega commit. And to make matters worse, it's not just concatenated, it's haphazardly thrown together to form this behemoth of a spaghetti which is overcooked and served without a sauce. Of course the taste is terrible. Of course it's hard to digest. Right? Like trying to make some sense out of it, it is really difficult. It is a very mentally taxing, energy-draining experience. It is time-consuming. It is frustrating. And I would argue that like for average people, such as myself, it is actually often impossible to properly, fully understand these changes. But still we try, right? What else can we do? We are asked for a review, and so a review we shall provide. But how can that which is unreviewable be reviewed? Now, there are two tricks of the trade here, and no one really tells us this. We have to come up with them on our own, and we do, because we have to survive, right? It's a self-preservation thing. So, the simpler of the two tricks, just approve the damn thing, right? So, like, I don't understand what goes on here, but I trust my colleague, and anyway, if there are some problems, they're gonna get the blame and they're gonna have to fix it, so hopefully it's fine. So I'm gonna approve. I'm not gonna make any feedback because I don't know what goes on here, but I can provide some nice uplifting message like, great job, you know, good work, LGTM, throw in a cute emoji for good measure, like a heart, a thumb up, or a rocket, hit the approve button, and I'm good to go, right? It takes a few seconds of my time, and now I can go back to producing my own monstrosity of a PR. Right? And there is like a more sophisticated approach. So here we actually try to provide some feedback. But because we don't understand these changes, we're going to focus on like more generic, superficial, shallow stuff. So I can say like, maybe this function is too large. I don't know what it does, but it seems to be too large. Maybe you should split it, right? Maybe some names are too generic or confusing. Maybe the documentation is sparse. Maybe the type specs could be better. I can always nitpick about line breaks, grammar, and spelling. Like if you're looking for a source of a lot of comments, focus on British versus American spelling. This is a goldmine of comments, you know. That and the Oxford comma, you know, that's my tip number one for making a lot of comments, right? And so I don't want to say this stuff is useless, but it feels a little bit like we're inspecting a building, completely ignoring the foundation, the architecture, the structure, the design, the utility, and we focus on the color of the paint in the walls, making the comments along the lines of, like, you know, I think turquoise would work better than cyan. Like, are we making a significant difference here? If we're honest with ourselves, the answer is probably no, often, right? But yeah, so as a result of this, you know, we ultimately approve things we don't understand. And so we more likely miss some more important structural issues. And so bigger problems can more easily make their way into the main branch, right, and into production. So things such as incorrectly understood requirements, unhandled edge cases, missing tests, crashes, memory leaks, privacy issues, security issues, and who knows what else. So that's a little bit unfortunate, wouldn't you say? But in our defense as reviewers, we can always say, like, look, I can only work with what I've got, you know. The PR was as it was, and so I did the best that I could, and so it is what it is. Or is it? Perhaps there is another way. A road less traveled by, which if taken might make all the difference. And it goes something like this. So we are assigned a PR for review, And we do our best shot, like we do a concentrated attempt trying to understand these changes. But we don't take a lot of time, like 10 minutes maybe at the most. And if within this time we see that we're making little to no progress, we give up. And we inform our author that we were unable to understand these changes. And as a result of this, we cannot provide an approval, but we also cannot provide actionable feedback, which would lead to an approval. Now, this is the reality of the situation here, and we're calling it like it is. And we should do this more often, and in my own small experience, I have seen this done exactly 0 times. So normalize returning PRs on the ground of them being not understandable. But this is by itself not enough. So we have to further reach out to the author and offer some help, to help them like bounce some ideas with them, discuss how can we actually clarify this PR, make it understandable, reviewable, maybe even pair with them. Of course, we want to help them merge their changes into the main branch, like their success is our success. We want to help them get some useful feedback, but faking it is not really helping anyone, right? More importantly, we want to establish this culture of nice, clean, reviewable PRs in the entire team, right? But what is it that makes a PR reviewable? So there are 2 things, 2 simple properties. This is such a low-hanging fruit, like standing there right in front of us, that I'm absolutely astonished how rarely do I see it being taken in practice. Right, so thing number 1, slash the scope. A PR does not have to implement the entire feature. And this is like the mistake number 1 that I see repeatedly. Too often, we conflate a pull request with a feature fully implemented from start to finish. A feature can and often should be split across multiple pull requests, which are smaller in scope and therefore easier to understand, simply because the amount of information is much smaller. And then you can, of course, use like a feature flag, for example, to hide the feature from your production users before it is completely done, right? But so what does small mean here? So first of all, of course, the number of lines of code changed is a somewhat shallow metric. Still, here's my guideline. The vast majority of PRs should change no more than 300 lines of code. Up to 5, yes. Above that, it goes exponentially worse. There are going to be exceptions, and that's fine. Like the simplest example I can think of is I'm changing some domain name, like some name which is widely used in my project. So it's going to be like a global search and replace. I'm going to touch hundreds of files, thousands of lines of code, and it's fine. It can be a single PR, it can be a single commit. It's very easy and quick to understand this change, right? And this is really what we're optimizing. How long does it take for like a normal, regular member of the team to understand the changes, right? So someone who is reasonably familiar with the language and the technology. I'm not talking about the junior. I'm not talking about someone who is senior, new to the team and new to the technology, like someone who knows Java but doesn't know Elixir, like myself, I'm not talking about guru, expert, Jose Valim, so just a regular member of the team. And for them, it should take typically up to 10 minutes to fully understand the changes. Okay. Yes, again, there are going to be exceptions. Maybe some fancy algorithm is implemented, so it's going to require some head scratching and contemplating, but most of the time, up to 10 minutes to fully understand the changes. And when you get that, you get some nice benefits. So first of all, the feedback loop is much shorter, obviously because it takes much less to actually produce a review, but also because people are going to be more inclined to start the review sooner rather than later, right? So like, I have 10 minutes of time on my hands. Like I have just pushed something and I'm waiting for the CI build to finish. Am I going to start a review or not? It depends. Like if typically I receive these monstrosities of a PR, which require like an hour or so to review, then no, I'm going to take a coffee break instead. Maybe I'm going to look at your stuff at the end of the day. Maybe tomorrow. Sorry, not sorry. On the other hand, like if I typically expect short, nice, clean pull requests, yeah, I'm going to start with 1. Maybe if I'm lucky, I can squeeze 2 in that short amount of time, right? So I want to get this stuff off my plate, and I want to unblock you as well. So you get much faster feedback. And this feedback is of much better quality. First and foremost, it is going to be less, there's going to be much less spam, this fake feedback, these nitpicks that people do just to kind of give an illusion of some sort of a review. So that might mean less work for you, the author. And then, in addition, it is more likely that reviewers can identify big, important structural issues. So in summary, we work faster, and we produce the output of better quality. Like, what are we even talking here? Make your pull requests smaller. Break your features across multiple pull requests. That's tip number 1. But it by itself will not be enough. Because even when it's small, it can still be hard to understand because a lot of different stuff is happening, even in smaller PRs. So what you need to do is don't just throw everything at once to your readers, right? You need to present your change incrementally, gradually, and you use commits for that, right? So if the entire history of our project was turned into a book, then individual features would be chapters. Pull requests would be sections, short sections, 1 or 2 pages, and commits are paragraphs. Each commit adds like a little bit of information to the story. Another one builds on top of it, more, and more. Commits are the fabric of your pull request. Use this fabric to weave your story. This is the story of your change. This is the story you're trying to tell to your readers, to your reviewers. All clear? Are we going to call it a day and go partying? Yeah? You know what? Indulge me just a little bit more, right? So let's make this a little bit more concrete. Let's make a pull request. And to do that, we need to make a change in a project. And as it just so happens, I have a project which is in a dire need of a change. And this project, it is called Hamlet. Now, the reason why it bears this name is because it currently, like many other projects out there, it is steadily marching towards a tragic fate. But you see, we're the authors of the story here, not some random bloke from the 16th century, and we get to decide the fate of our hero. And we're going to do our best to save our hero, to allow our Hamlet to live long and prosper. And the way we're going to do this is we are going to collect some metrics. So this will allow us to watch over our system and see when things are taking the wrong turn. And if this happens, we can take some corrective measures. We can perform a divine intervention of a sort, which will stop our system from, making some unfortunate decisions with tragic consequences, right? So specifically, we are going to collect utilization of Beam or Erlang runtime schedulers. And as many of you know, a scheduler is an OS thread which runs our code. It is the processor of our instructions. There are 2 types of schedulers which are relevant for this story, normal scheduler and the dirty or dirty CPU one. Their purpose doesn't matter for the story, only that there are 2 types. And there are going to be multiple instances of each scheduler typically, so like you will have as many threads or as many schedulers by default as there are CPU cores available on the host machine. So like here, on this modest machine, I have 20 CPU cores, so I'm going to have like 20 normal schedulers and 20 dirty schedulers. And so what I want to do is I want to compute the average utilization of all of them. And this gives me an indication of how busy my system is, right? How loaded my system is. And then I can like plot this on some nice dashboard. I could have some alerting logic in place, which informs me when I'm reaching the point of my maximum capacity or the point of being overloaded. And of course, I could have some auto-scaling in place based on that value, right? We're not going to implement all of that, obviously, right? There's not enough time. But I'm not even going to finish a PR. I'm just going to start, show a couple of commits to make some points, and then in the 3rd act, I'm going to show you a finished PR, which is already available. I just made it public before the talk, so it's on my GitHub repo, and the repository is called Hamlet, and you can see the PR, and you can study it at your own convenience. Okay, are we ready? Vamos? Okay, let's do this, people. So first of all, of course, you need to do like a little bit of research, right? So we need to figure out how can we compute average utilization, and like if you will consult AI, maybe look at the documentation, and hopefully, if you're lucky, you're going to find out about this function, which is called scheduler sample. So it basically gets the sample of all of the activity time for each scheduler. So how busy was each scheduler like since the dawn of time until now? So I take the sample. I'm sorry? Increase the font or what? Okay. Is it good now? Okay, so I invoke scheduler sample once, now I invoke it for the 2nd time after a while, and I get another sample. And then I have like this nice function which is called scheduler utilization. I pass it the 1st sample, the 2nd sample, and it gives me the utilization, right? So we have, for each scheduler, this is the type, CPU means dirty CPU. This is the ID, we don't care about that because we're going to aggregate. This is what we care about. This is the utilization, like a straight float, so 0 means 0%, 1.0 means 100%. And the final one is Erlang string formatted, or charlies, right? We don't care about that. So we get this for each CPU scheduler, for each normal scheduler, and then we can like compute the average. But as it just so happens, this is actually done for us already, so I have it here for this total triplet. So this one doesn't have the ID, obviously, so I can just extract this value, and this is the total utilization of my system, of my schedulers, okay? And so I've done a little bit of research, and now I know like which functions I need to invoke. And now I can think about like what would the solution look like. So what I need to do is like periodically grab the sample, compute the utilization based on the last sample and the one before, store the sample and the utilization somewhere in memory, after a while rinse and repeat, okay? And then of course expose the utilization to other pieces of the code. And if you're like reasonably familiar with OTP, then this really screams Gen server. So like with Gen server, it really fits this problem very nicely. So you basically what you do in Gen server, you tick. This is how I like to call it, tick. You periodically execute some piece of code, and this is exactly what I described now. You can use process send after function to do this. So Gen server sends itself a function in the future. It handles the function by running this code, sends another function, sends another message in the future, and this is how you periodically tick. So now we have like a sketch of a solution, and so we can start coding. But first I have to open up a branch, obviously. Before I do that, I need to make a personal confession. So just between you and me, right? What happens in Braga stays in Braga, okay? I use Git from a GUI, okay? I don't use it from a command line. I don't know how to use it from a command line, right? So you see, I read on the internet, and so it must be true, of course, that real programmers only ever use Git from a command line. And so I suppose it means that I'm an unreal programmer. And you know what? I'm going to take it. You know, there are worse things in life. I'm going to wear this badge with an honor. So, but that was a small personal digression. I apologize for that. So let me move on to my GUI of choice, which is called Smart Git. No affiliations whatsoever. You know, I'm just a happy user for more than 10 years. So I'm going to open up a branch, and let's call it Measure Scheduler. Utilization. Sorry, I cannot enlarge this font, but we're not going to spend a lot of time in Smart Git anyway. If it helps, I also have problems reading, so I'm reading from this thing here, because this is Linux. Because this is Linux and I couldn't make the mirror mode, yeah. Anyway, we have our branch, yay, right? And so now, you know, I could start banging on the keyboard, producing some code, but maybe like it's too many things at once. I cannot tackle all of this at once. So it's like good to think about like some small steps that I could do, like how can I progress? So I could, for example, implement a Gen server which ticks every second. It does nothing in a tick. It just enqueues the next tick, right? And then I can start expanding on it. I could, like, for example, collect the sample on each tick, then calculate average utilization. Then I can expose average utilization, start the thing in a supervision tree, and then it's probably time to write some tests, and I'm not really sure how that's going to look like. Probably it's going to require some mocking, so I'm going to cross that bridge when I come to it. But I have like a reasonable, you know, it's vague, incomplete plan. So, right, what I need to do here is then, let's write a Gen server which ticks every second. So what I'm going to do is create a file. I'm going to call it scheduler utilization.ex, and now I can write this Gen server. But you know what? Another personal confession here. So I'm not going to lie, I'm a little bit nervous here, right? You know, standing here in front of you, coding. I'm worried that I'm going to embarrass myself, you know, make a rookie mistake, ruin my reputation. So what I'm going to do instead is I'm going to reach for some assistance. I'm going to summon a mystical, magical creature, not made of flesh, you know, an unreal programmer itself. And this creature, it is known to us mere mortals under the name of Sonnet, Claude Sonnet, 3.5. So let us ask Claude to write us a Gen server which ticks every second. Okay, are we ready? Let's do this. So let me maybe zoom this in a bit more so you can see it more clearly. Okay, let's see. Okay. So it seems nice. Yeah, it seems. Let me scan it. Yeah, it seems okay. So you know what? I'm going to take it, right? So thank you, Almighty Claudius. Praise be thy name. Hamlet shall never forget. Yeah. So let's take it for a ride, right? So let's see what happens. What I'm going to do is I'm going to open a script file in temp folder, so it's like not accidentally committed. This one is git ignored by default. Oops, what did I do? Let's just close this thing. Okay, so what I have to do, what is it called? Hamlet scheduler utilization, right? Dot scheduler. What did I do? Why do I always forget how to type when I'm on stage, you know? So probably start link, and I have to pass some options, which are okay, so it doesn't really matter. And let's see if it works. So mix run minus no hold, temp / test exs, and yay, it's working, right? So, yay, well done, Claudius. So, you know, I have to say, like, I was a bit skeptical, but the vibe coding hype, it is real, people, you know, like, even a 16th century wannabe poet can write concurrent code these days, you know, like, what a time to be alive, right? So, okay, so before proceeding forward, let me just sprinkle a wee bit of Stardust on top of it, right? So what I need to do here, yeah, we don't need this default here, so I'm just going to delete this thing, whoopsie, like this. I like to call this arg, because it's like an arg. We don't know what it is, but we need an argument because of how UseGen server injects the child spec function. This is all explained in the documentation, also the good book, aka Elixir in Action. I'm going to remove this name, schedule next heartbeat, maybe tick. Okay, this is really now nitpicking here, but you know, I feel that like ever since AI arose, that I'm reduced to just nitpicking, you know. So that's it, unfortunately, such is my fate. This is nice and dramatic, but maybe too poetic. Maybe let's make it a bit more mundane. I'm going to leave this IO puts for the moment, and let's just see if it's still working. Yes, but I have forgotten one important thing. So this is supposed to be like a production code, right? So I'm going to do at impl gen server. Don't do at impl true. It's lazy, you know. Provide a callback module, right? And finally, I can drop this thing. We don't need this anymore, right? And so now we have, oh, I forgot a pet peeve of mine, you know, sorry, I have to do this. I cannot proceed if I don't do this. So replace this magical number with timer, oopsie. Timer.seconds, yeah, make it more descriptive, yeah. Okay, and so just one final, I'm going to see if it's not breaking. Of course, it's not printing anymore because I deleted it, but it seems to be running. Okay, so the next thing I need to do is I need to collect scheduler samples, right? But before I do that, I'm going to commit this thing. So let's go here, and now I need to, this is going to be tricky. So what have we done in this commit? We have, for example, created periodical ticker, okay? Bam. So here comes the big moment of this talk. Prepare to be blown away. Work in small steps, commit each small step. It's not exactly mind-blowing, is it? You know? So why don't we do it? And one theory that I have is that too often we try to code our way through the problem. We conflate preparation and the execution. And so we stumble in the dark, you know, we don't know where we're going. And this is why we have full bar, buzz, blah, and similar commits, right? Our history reflects how basically we don't have a strategy. So separate preparation from the execution, right? Do a little bit of upfront work. It doesn't have to be a lot. So understand the problem, then try to figure out which functions do you need to invoke to actually solve that problem. So you can use AI for that. You can use like forums, documentation, and yes, you can code. It's okay to code to figure out what you need to do, but don't try to implement the full implementation then, right? Just try to find out like what you need to invoke. Once you know that, then you think about how this fits into your larger design of your entire program, and then you can devise a plan of how to work in small steps. And all of a sudden, you have this beautiful yellow brick road taking you from the start to the end, right? And so you work in small steps, you have this nice pace, and at each step you deal with just a single thing. You're not trying to solve everything at once, right? And so this is actually going to make you faster. I mean, working in small steps, it is such a universal advice, right? Not just for programming, for anything. And the reviewers, the reviewers. they are going to feel as if someone transported them from the Stone Age straight into the Vibe era. They're going to see things so much more clearly. They're going to be so much faster. They're not going to know what hit them. Right? So again, everyone on the team is faster. And this happens because we separate planning from the execution. We do a little bit of upfront planning, right? So as the old saying goes, weeks of coding can save you hours of planning. Okay, so let's proceed. Right, so we need to collect sampling logic. Now, where's my mouse? Oh, here it is. So I'm going to do something barbaric. I'm actually going to write some code. I'm relaxed a little bit now. So what I'm going to do is I'm going to get a sample, and it equals scheduler.sample, right? And so now I have to store this thing in the state. So here I'm going to update, and up there I'm going to store this thing, and this is it actually. So now I need to see if this is working. So in the test script, I'm going to take the PID. Is everything all right back there? I'm going to take the PID, and then I need to get the gen server state. You have like this nice little function, sysGetState. Don't use it in production, so just for testing and debugging purposes, right? So I'm going to dump this to IOInspect, and then I'm going to do this after the next tick. So I'm going to process .sleep for 2 seconds, right? Again, reminder, use this. Okay, so I'm going to sleep for 2 seconds, so this ensures that I have like at least one tick ready, and let's start this thing. And bam, it's crashing spectacularly. Function scheduler sample is undefined, model scheduler is not available. So yeah, I need to add the extra application here, which is called runtime tools. So this is the stock Erlang application, but you need to edit. You want to edit anyway, because this is like the observer backend. So you want to have this for like better operations. And so let's run it again, and it prints a state. And after 2 seconds, another state. If you paid close attention, the numbers have changed. So we are collecting samples now. Maybe I could also like add, let me do it here, some nice comment, more for a reviewer than for myself, like so they see where I'm heading with this average utilization, and I'm good to go, right? And so now I can commit. So I have 2 changes. Yeah, sorry that this is so small. So I have changed mix CXS and scheduler utilization, and I'm going to commit those things. And what have we done here? We are collecting, collect scheduler samples. Now, you might be tempted to split this into 2 commits, right? Don't do that. As Fred Bear likes to say, don't drink too much Kool-Aid, right? So these 2 things are part of a single logical change. We can give it a reasonable common name, and so it doesn't make sense to split them. It's actually more confusing to read if they are split, because like when you read it together, you see, oh, Saša added runtime tools, and in the same commit, he's using this scheduler module. So clearly, that's the reason why. It's a nice small change. It fits together. It's part of a single logical step. So keep them together. Of course, if the change is big, then you want to consider some splitting. Speaking of commit messages, like if you write commit messages along the lines of change migrations, change schemas, implement business logic, add tests, and refactor, chances are high your commit is unfocused. If you feel you need to use AI to summarize your changes, chances are high your commits are unfocused, and they need to be split, okay? It should be take 10, 20 seconds to give like this short, nice context, nothing more than that. The implementation speaks for itself, and because it's nice and small, it's typically very quick and easy to understand, okay? So, collect scheduler samples, and let us move forward. So the next thing I need to do, calculate average utilization. So what I'm going to do is I'm going to say average utilization equals this. And I'm going to pass the last sample, so that's state.sample, and I'm going to pass the new sample, and then I'm going to store this thing in this state, and for this to work, I need to have it in the initial state, and because I only have 1 sample, then initially I can only set it to 0, and now the only thing remaining is implementing this function, so I take 1 sample, and I take another sample, and I pipe the first sample to scheduler utilization. Oops, that's scheduler.utilization. Man, okay, like this, and then I do pass the other sample. Then I need to find that total triplet, so it's enum.find, where the element of the tuple at the position 0 equals total. And literally then, I get this, and it's always going to be present. So total, and I get value I care about, and I get formatted I don't care about, and I'm going to return the value. Whew, okay, that was a little bit more work, but we're finally done. Let's take it for a ride. So, okay, so we initially 0, and after a while, like some super small number larger than 0, so we are computing something. Does it make sense? I don't know. We're going to test it a little bit later, but let's proceed a bit forward before we do that. So let me commit this thing. So what I've done here is I'm calculating average. Did I spell this right? Can anyone actually read this? Average utilization. Okay. Right, so the next thing I want to do is expose this thing via a getter. So this is a simple like average. I'm not going to add the utilization suffix here because it's a part of the public API. So like scheduler utilization, not average utilization. It's lazy, you know, so and confusing. This is a pet peeve of mine. So anyway, it's going to be genserver.call to the PID, right? I need to pass a PID here to the PID, and let's call it average. Oh man, okay. And so now I need to implement it, so like this, Gandalf call. Handle call, maybe I should have done it like this, yeah. So request is average, just plain average, from, we don't care about it, state we do, and we reply with state.average and state, like this, okay? And hopefully that is it. So let me close this mix.exs. So to test it, I can finally get rid of this thing here. So this is now hamlet.scheduler.utilization.average, and now it reads beautifully, okay? And let's see what we get. So yeah, 0, and then some other numbers, so we are still good. And let me commit this thing. So what are we doing here? We are exposing average utilization, like this, okay. And so now finally I can test this thing. Like, is this number actually meaningful? By testing, I mean manual testing, not writing tests yet. So that's not going to happen in this talk, unfortunately. So how can I see if this number is meaningful? I can generate some synthetic load, right? So I could like I could hammer a single scheduler to 100%. So I could spawn a process and maybe do something along the line of stream.cycle through this list of single element, and then I can just pipe this thing to stream.run, and this is going to be an infinite CPU bound loop, so it hammers a single scheduler to 100%. But you know, I have 40 schedulers here, so I'm going to reduce this thing to maybe reason more easily about this number. So I'm going to use Erlang system flag, and the flag is schedulers online, and I'm going to set it to 1. And what this means is I'm still going to have 2 times 20 schedulers, but only one of each is going to be used, okay? So I expect to get 0.5 or 50% because there is one normal scheduler which is fully busy and one dirty scheduler which is fully idle. So let's see if we can get that number. So initially 0 and then 0.025. Okay, that's quite small. Perhaps it was a glitch in the matrix. Let me try it again. No, it's consistently wrong. Oh, woe is me. It means that something is rotten in the state of my gen server. And what could that be? Oh yeah, of course. So it's this thing here. So this total thing that's computed for us courtesy of this function, it actually calculates the average of all the schedulers, right? So not just the online ones. And so it's actually not sufficient for me. So I have to rewrite this whole thing. I have to compute the average myself, unfortunately. Such is my fate, right? So utilization equals, let's take it like this. So just, that's the final coding session. Bear with me here. I'm going to delete this thing. And what I'm going to do then is I'm going to iterate through this list. Let's call it utilizations because it's a list. And so I look for normal, don't care about ID, care about the value, don't care about formatted. So for all such tuples in the list of utilizations, what I do is I extract value. And this gives me normal utilizations, right? And so now I do the same thing for the dirty. So this is dirty here, and it is CPU here. And then I need to take only the online ones. So I'm going to do something like enum take, normal utilizations. I'm going to take as many as there are schedulers online. Yes, okay. And now I need to do the same thing for the dirty ones. So here I'm going to do dirty, as there are dirty CPU schedulers online. And this gives me my online, not on-client, online utilizations. Beautiful. And finally, the last step, I can compute the average. And this is basically, I sum these elements, and I divide it by the length of the list, right? And this is, like you might be worried that this is going to be possible division by 0, but it's not, because it's a non-empty list. Because if this code is executing, then there is at least one online scheduler. So QED, right? Okay, let's see if it's working. 0, and then, yay, in the first attempt, I don't see this happening every year, Is it a leap year already? Okay. So, yeah, one important thing. So what I want to do here is I want to clarify why am I computing this manually rather than using total. Hopefully, I don't have to clarify how. So I try to use like these paragraphs and some descriptive names. And so hopefully, knowing the motivation, it should be like reasonably straightforward to understand how am I doing it. And so now, what are we doing here? We are like, for example, improve average calculation, right? But now, here's the thing. Here's an important thing here. Like, do the reviewers actually have to see the first version? And I would argue not, So I had like this wild goose chase, this dead end, and a couple of commits later, I figured out that like, no, actually, this version is completely wrong, and so I'm going to implement a new version. And so why don't I try to hide this from my reviewers, right? And so what I'm going to do an attempt to do an interactive rebase. Now this is going to be fun with this like super small font. So basically, I'm going to try to bring this improve average thing over there to this commit. And now I'm going to try to squash these two commits. And the message is going to be calculate average utilization, right? So let's do rebase. And we don't have any conflict. And so the log looks like something like this. Let me just move it over there and maybe try to zoom it in. So I have create periodical tickle, collect samples, calculate utilization, blah, blah. This commit here, penultimate, average utilization, now contains the second version of the algorithm immediately. So our reviewers do not see my failed attempt. And I try to do this. I do this regularly. This was perhaps a bit more elaborate example, but sometimes I forget to add like a type spec, or maybe I figure out a couple of commits later that my name was actually incorrect or misleading. And I try to bring those changes back to the past if I can do this easily, right? I don't do this to make myself look perfect, but to try to hide these like sidetracks, these irrelevant things from my reviewer. That's the idea. But I'm not like, if I get a merge conflict while rebasing, I'm going to give up, So having these small imperfections is okay, You want to try to look for some balance, which doesn't take a lot of your time, right? You see, like, we should do these things, not because they're hard, but because they're easy, and because they improve quality of life of citizens of our team, okay? So there are quite a lot of things I need to do, but unfortunately, I'm going to have to stop here because I'm running out of time shortly. So instead, my most cherished audience, I present to you the pull request. Feast your eyes, marvel at its glory. Behold the commits, they tell a story. Right, so like, if you look, let me try to zoom this in again. If you look at the, where's my mouse? If you look at the commit titles, right? So create periodical ticker, collect samples, compute average utilization, expose it, run thing in the supervision tree, test the average, and now we have just testing stuff. So you can see how the story unfolds. You can see the scope. Even without reading the description, you can already see like what I didn't do. I didn't do like the dashboard, the alerting. I didn't do auto-scaling. This stuff is left for some other pull requests, right? And this is an example of, another example of how you can split the change. This is a nice, well-shaped PR, right? So it's 150 lines of code change. You can see it like over there on the right, and spread across 13 commits. Okay, so on average, it's less than 12 lines of code changed per single commit, right? Of course, it's not going to be that uniform. Let's see if we can walk through just a couple of them. So the first one, right, the Gen server, 21 lines of code, a little bit larger, but nothing specifically smart here. If you're reasonably familiar with OTP, you're going to do just fine. You know, it takes maybe like 20, 30 seconds to stop here and look at what goes on, right? The next one, so this is collecting the samples. I should warn you, so those of you who pay close attention, it's a little bit different than what I've coded. So long story short, this is a more production-friendly version, and what I did was a more demo-friendly version. You know, but anyway, again, it's a nice small change, fits on a single screen, pretty much should be straightforward. And then we have another thing. So this one is going to be perhaps a bit of a head scratcher, right? So the algorithm, the average. But here's the fun thing. So you read this thing in isolation, right? You don't care about anything else in this PR when you're in this commit. And so you can focus on this thing, you can maybe make some comments and whatnot, and once you're done, you forget about how I calculate the average. You just know that somehow it is calculated, right? That's the beauty of small commits, you know, and working in small steps as well. Another thing that I want to quickly talk about before I finish up. So this is the first commit I didn't live code or wipe code. So here I'm starting the server in the supervision tree. And as a part of this change, I'm giving it a registered name, right? So basically, I'm giving it because it is a singleton in the system now, and I want to interact with it. And so the most typical solution for that is giving a registered name. Now, you may remember that Claude originally generated a registered name, and I explicitly deleted it. I actually knew up front that I will probably need this Gen server to be registered because I spent some time thinking about the problem, and still I didn't do it. I explicitly removed it because I didn't need that change at the time, you know, so I'm adding it when I'm needing it. So there is this technique in storytelling. It is called the setup and the payoff, right? So in setup, you provide some piece of information, and then much later down the line in the payoff, you use this information to resolve some more important plot. So for example, we could, at the beginning of our story, we could say casually how our protagonist knows how to pick locks, right? And then the story goes on, and we almost forget about this small detail, and near the end, the protagonist escapes the prison, you know, using their lock-picking ability, right? This is precisely what you don't want to do in this kind of a story, okay? We are not writing a piece of art here. We are not aiming to win a Nobel Prize or some other kind of literature award. So forget about red herrings, plot twists, suspenses, cliffhangers, nonlinear narratives, and such, you know? This story should be like stupid formula fiction, pulp fiction of the worst, cheapest, simplest kind, you know? Something along the lines of, evil Claudius threw Hamlet into a dungeon, but luckily, Hamlet knows how to pick locks, and the guards didn't take his tools from his pocket, and so he escapes, right? This is the good stuff, okay? This is what we're aiming for. You want to keep your setup and payoff as close to each other as possible, because this is easy for your readers to understand, you know, how they work together, right? So ideally in the same commit, and if you know the amount of changes is larger, then of course you may want to split them, but you want to keep those commits close to each other, okay? So whenever I review this kind of a PR, which is sadly far too rare of an occurrence, you know, it's always the same. I go through these commits like next, 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 you know, spend like a couple of seconds, you know, scratching my beard, and like, yeah, makes sense, seems nice. And so I reach the end, and always, every time I swear, I press on the next button and it doesn't go further. Like, why? Is my internet down? You know, I try to restart the router, and no, I have actually reached the end of the PR, and I understand everything. It took like some 5 to 10 minutes of my time. Wow, it is possible. And you know what I do then? I do LGTM, cute emoji, approve button, right? And so now we've done the full circle, but now it is earned. It is earned by you, the author, and you will know when it is earned, just like you will know when it is fake. When you receive like a quick approval, maybe 10 minutes after you have submitted it for review, if you have done your job of making it small and nice and understandable, then you will know that probably your teammate actually understood these changes and they have nothing to add. And this increases your confidence that your changes are solid, which is arguably the most important point of the code review. And you can get this point by splitting or by making your pull requests nice and reviewable, making them small and organizing and presenting your change. Okay? So, time to wrap this up. Let me go back to my slides. Okay. So, when all is said and done, when all the smoke disappears and all the mirrors are shattered, here's what remains of this talk. If you're practicing code reviewing in your team, if it's a mandatory practice, then as an author, you're not just implementing a feature. You are not just trying to solve or fix a bug, improve performance, reduce memory usage and such. You also get to decide how easy or difficult it is for your colleagues, for your reviewers, to climb up to the top, to reach that point of complete understanding of your changes. You get to decide if they can even do it. So kindly show some empathy, consideration, and make the job easier for them. You definitely don't have to go above and beyond, right? You don't have to make your history look perfect, because perfect, of course, is the enemy of done. But at the same time, let us not forget that ASAP is the enemy of good enough. So try to find that nice sweet spot, that nice little balance, where a little bit of your effort is going to make a tremendous improvement for many other people on the team, and you will be faster too. Because what goes around comes around, and I can guarantee you that the quality of the pull requests you receive shall match the quality of the pull requests you give. And so, with these parting words of sweet sorrow, my most esteemed colleagues, Beamers, friends, this talk is done, the curtain falls, gather outside, discuss in the halls. May pull request a story tell, I humbly ask and bid farewell.